In today's lesson, we're going to be calculating the volume of prisms. Firstly, I think it's important to remember that volume is simply the space inside of a 3D shape. To start off with, I'd like you to pause the video and work out the volume of the three shapes at the bottom. You can assume that each cube in your diagram is equal to 1 centimetre cubed. So, here are your answers. In part A, we can start off by looking at the number of cubes on this front face. That's 1, 2, 3, 4, 5. Those 5 cubes repeat itself throughout the whole length of the shape, which is 1, 2, 3, 4 cubes long. That therefore means that the volume is simply 5 times 4, which is 20 centimetres cubed. We can use a similar strategy to work out parts B and C. So for part B, the number of cubes on the front face are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. That's 30 cubes on our front face. I know this repeats itself along the length, that is 2 cubes long. That therefore means to work out the volume I need to do 30 times by 2, which is 60 centimetres cubed. Doing the same for the last example, I know the number of cubes that I'm given are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 on the front face. I know that that repeats itself along the length of the shape, that's this bit just here. And I know that that is 1, 2, 3, 4, 5, 6, 7 cubes long. Therefore, to work out the volume, I can do 20 times by 7, which is 140 centimetres cubed. All of the shapes in this question are prisms. That's because the end face repeats itself through the length of the shape. As we did for these 3 examples here, we can use that fact to help us work out the volumes of prisms really easily. I can start off by saying that the volume of any prism is simply the area of its cross-section times by the length. In my 3 images, I've got a cuboid, a triangular prism and a pentagonal prism. Highlighted is their cross-sections. As you can see, their cross-sections run through the length of each shape. For the cuboid, we've got a rectangle. For the triangular prism, it's a triangle. And for the pentagonal prism, it's a pentagon. This means that as long as we can work out the area of the cross-section, we simply times it by the shape's length to work out its volume. So here's some examples of that. In each of these examples, the cross-section is given to us. For part A, I can say that the area of the cross-section is 11 millimeters cubed. If I times this by its length, which is 8, I get 11 times 8, which is 88 millimeters cubed. That would be the volume of the shape. Again, in part B, I know that the cross-section is 9 meters squared. Multiplying this by the length of 7 gives me 9 times by 7. That's 63 meters cubed for the volume. Lastly, for part C, the cross section is 15 meters squared. I times it by the height, which is 5, and 15 times 5 gives me 75 meters cubed for the volume. Obviously, we're going to have to work out questions that are a little bit harder than that. If we look at this example here, we have a triangular prism. To work out its volume, we first need to think about the area of the cross section, that's the triangular face at the end. So here's our triangle. I'm going to start off by labelling it. I know that the base is going to be 4 centimeters, and I know that this height just here is given as 5 centimeters. That is our cross section. Now, to work out the area of this cross section, I know I need to do base times height divided by 2. That's 4 times 5 divided by 2. 4 times 5 is 20, and half of that is 10, meaning that the area of my cross section is 10 centimeters squared. To get my volume, I'm going to need to times the cross section by the length. So I can say that the volume is the cross section of 10 times by the length, which is also 10, which gives me 100 centimeters cubed as my answer. I can repeat these steps to work out the volume of this shape just here. Firstly, I need to consider the area of the cross section. That's this shape just here. I know the lengths that are given are 4 meters on the top, 8 meters at the bottom, and that the distance between the two parallel sides just here is 5 meters. Because this shape's a trapezium, I can use this to work out its area. Doing this, I first need to add the parallel sides. That's 4 add 8, which is 12. I then half this answer. 12 divided by 2 gives me 6. And then need to times this by the height, which is the distance between the parallel sides. That gives me an answer of 30. That means that my cross section has an area of 30 meters squared. I can now work out the volume, because the volume is simply the area of the cross section, which in our case is 30, times by the length of our 3D shape, which is 6. 30 times by 6 gives me 180, therefore the volume of my shape is 180 meters cubed. That is my final answer. Now, the only way that they'll make these questions harder is by introducing compound shapes as the cross sections. Again, if I want to work this out, I first need to consider the cross section of my shape. I'm going to begin by labelling this. So I know that this length is 4 meters, I know this right hand side is 11 meters, this length is going to be 6, and this left hand side is 7. It could be that you need to work out some of the other lengths that you are not given, but in my particular example I can use just these lengths. Now, to work out the area of this cross section, I'm going to split my shape down this length just here. I know that the right hand area is going to be 4 times 11, that's 44 meters squared. The left hand side is simply going to be 6 times by 7, and that gives me 42 meters squared. That means that my cross section is going to be the sum of these two answers. 44 plus 42, that's 86 meters squared in total. I can now work out the volume by timesing the area of this cross section, which is 86, by the length of my prism, that's 13. Obviously, to work this out, I can use a calculator to help me. So I can get my calculator. I need to put 86 times by 13, and that gives me an answer of 1118. So that means the volume of my prism is 1118 meters cubed. That's my final answer. So there are 2 tasks for you to complete today. The first of them is the structured volume of a prism worksheet. The table is split up, so it first asks you to label your cross section, use this to work out the area, and then lastly times that answer by its length to get the volume of each prism. Once you've completed this task, please check your answers very carefully against those that are provided on Show My Homework in the Resources to Help You section. It's really important that you've got all of these correct before you move on. Your second task is to complete this volume of prisms worksheet. The questions on this worksheet get progressively harder but do not offer the same structuring as what the previous worksheet did. Question 1 always gives you the cross-section and you simply need to times this by the length given. In question 2, you're required to work out the cross-section individually using the area facts that we've already looked at. Question 3 introduces compound shapes as the cross-section. I strongly recommend that you draw the cross-section out for these questions. Again, once you've finished, you can find the answers to these on Show My Homework in the Resources to Help You section. Please make sure you check your work really carefully, and if you have made any mistakes, try to go back and correct them before submitting your work. Once you've done this, take a photo and upload it to Show My Homework so I can see how you've got on. If you are struggling to complete some of the work from today's lesson, then please do not hesitate to get in touch via comment on Show My Homework. I'll try to make myself as available as possible and get a reply to you as quickly as I can. If the issue requires a little bit more input from myself, I might ask to arrange a time to meet on Teams where I can give you some personalised help with that specific problem.